So in the previous video, I looked at how to use the group by function to create a cross-tabulation of two variables. In fact, Pandas actually has a function called crosstab to do precisely that, and I think in some ways this is an easier function to use. So let's look at how to use this crosstab function here to do a cross-tabulation of site by gender, as I did up here. So it's a pandas function, so we use the alias pd dot and then the function crosstab. Now remember, of course, if you want to know what options are available, what the syntax is, you can use the help facility, the built-in. You just, of course, put your cursor on the function and press Shift Tab, and up comes this nice little help system with showing the options and the default values and more information about the options and a few what the function returns, a data frame containing obviously a cross-tabulation. A few notes here, some examples, quite useful. If in fact you want to know a little bit more about the particular function, you can always go to the website for the particular package, in this case pandas. So if we look here at the pandas website, here it is at pandas.pydata.org. All the main functions that you use in for data analysis in Python, pandas, numpy and so on, matplotlib, all have excellent web pages with lots of information. So here, for example, you can well, we know how to install pandas. We've looked at that via PyCharm. You can look at getting started. Here, if you want a very simple introduction, hopefully you wouldn't need that after you followed these my tutorials. There's a user guide which contains information, a lot of very useful information about the various parts of pandas. As for looking up a particular function, if we go here to API reference and then either look under these headings here, or easier, just search for it. So I'll search here for crosstab. And there we have the function there. And here, as you can see, this is essentially what was in that little help system, but in more detail. The various functions with the default values, if they have one, of the parameters, or the options as I sometimes call them. Obviously telling you what it returns again, some related functions, some notes, some examples, basically what's in that help system, but perhaps a little bit more detail here. I find these pages very, very useful. So let's look at how to apply this. So I'm going to use a crosstab function here to get a breakdown of site by gender, as I've done up here using the group by function. So I'm going to reproduce these values here. So what you have to do in this case is first of all put the variable which is called the index variable. That's the one that you are breaking the results down by. It's the one that goes in on the left hand side of your cross tabulation, and the one that you're breaking down, you're categorizing by gender, is the one that goes along the top, and that's site. Now notice here I have to indicate those particular variables in my data frame. So using the standard syntax df, and then in square brackets, of course, the column name, the variable name, comma, and then the other one. Now, the nice thing about the crosstab function, which is why I think it's better than the group by, is that you can also get column and row totals, or column and row values as well, which I couldn't get just using group by. So all you have to do is to put margins equals true. So if we run that, we'll see what we get. And as you see, you get a nice little, something that looks a bit more like a standard cross-tabulation than what we had here. But with the same values, obviously, but arranged in a much nicer way. And also, as I say, you've got these row and column totals, and of course the overall total, which of course is 20, there's 20 cases. So I think that's such, I prefer this. And also, Unlike up here, where if you remember, I couldn't turn these into percentages by simply including the normalize equals true and then times by 100, which I did for a simple frequency. I had to resort to this transform function. With the crosstab function, you can. Again, all I need to do is to put normalize, if I can spell it correctly. Notice I'm using that shortcut of pressing the tab key to get the to bring up to the option quickly, and then just press enter, and then we want true. That needs to be have a capital T at the beginning. Now that will give me proportions like that, and obviously I want those percentages. I just times by 100. And there we are, very nice. I've got these proportions just as I had here, but this time I've got the row and column values, totals in this case. So as you can see, 45% of respondents were female, 55% male, 35% of all respondents chose Facebook, 25% Pinterest, 40% Twitter. These are these. So as well as the breakdown in terms of site and gender, so these values here, of course, are the same as these. I get these nice totals as well, these margin totals, as they're called, much easier than having to resort to in fact here all I got here, of course, was the percentages. But here I get even more. So this is definitely better, I think, than using the group by in this particular case. And of course, you could easily you could store this in a separate variable if you want, and then put it into and then use it as I've done here to draw a nice graph. If you did that, notice that there would in fact be 4 columns. There'd be one for Facebook, Pinterest, Interest, and then one for all. So here you'd have to make sure that you, sorry, no, that would work fine. Your legend would come out fine. There'd just be an extra option here. You wouldn't need to do anything else with the xticks function. Now, the other thing that you might want to do in terms of a cross tabulation is to break down the responses to the usage to a numeric variable, in my case this usage in hours per week variable, according to a couple of the other category variables. So, but of course with a numeric variable, what you can't just show the count of values in any particular cell, because each cell would be unique. You'd just be basically reproducing your data set. What you need to do with a numeric variable, of course, is to aggregate the values in a particular cell. So for example, you might want to know what was the average usage in hours per week of men who chose Facebook as their main site. So this 20% of respondents here, men choosing Facebook, what was their average hourly usage in hours per week? Well, for that we can again use the group by function and again group site by gender, but then we indicate that it's the numeric variable usage in hours per week which we want to show within our cross tabulation, and we want the mean of those values. So this is going to give me a cross tabulation where the values in each cell will be the average, the mean hours per week of usage of these 6 sort of subcategories: women who chose Facebook, women who chose Pinterest, men who chose Twitter, and so on. So you can see how to do that. It's the same syntax here for the group by function as I used up here. Exactly the same there, but rather than putting site here and saying I want the counts of site, what I want is usage, hours per week, and I want the mean of that. So you put the mean function here, dot, and then mean, and since it's function, you put the brackets. So now I'm storing that in this variable mean underscore usage, and then displaying it. And there we are. You can see those. That gives me a breakdown of by gender and site, and the value in each cell here is the average, the mean hours of usage of those particular respondents, women using Facebook, men using Pinterest, and so on. Again, in fact, you can do this much, very neatly and in some ways easier, I think, by using the crosstab function. So here you can see how to do it. So this is the same syntax here. So I choose the two variables, one for the what's called the index, the variable down the left-hand side, one for site, the one across the top, that's called the column option. But rather than, and then I can get the margins as well, again, something I can't get here. So this is another advantage of the crosstab function. And to specify these two things, as I've done here, that I want to use this variable and I want to aggregate according to the mean, use these two parameters, these two options, values equals, and there you specify the numeric variable that you want to aggregate. Of course, in my data set, I've only got the one numeric variable, usage hours per week. And then using the agfunc, AGGFUNC, it's obviously standing for aggregate function, you tell it which function you want to use. Notice here you put that in inverted commas and you don't need any parentheses at the end. So this is going to do exactly what I've done here, but I will also get the overall average of men and women and the overall average of people who use Facebook and so on, average hours per week. So if I run that, you can see again, I think this is definitely preferable to this in terms of presentation, but also in the fact that you get these overall averages here. So we can see that looking at all women together, regardless of what site they chose, they on average spent 35 hours a week. All men spent 29.45 hours a week. If you just look at all the respondents who chose Pinterest, regardless of whether they were men or women, they spent 19.6 hours on average per week on Pinterest. So again, I think it gives you more information. It's often useful to know these margin values, as they're called, as well as the individual ones, which you don't get with this. Just one little thing to mention here, but notice that here the values here are only show at the most 2 decimal places. Now the reason for that is that I set this option at the beginning here called PD, it's a pandas function, so PD dot and then set underscore option. Now there are various things, lots of things you can set here, but one thing you can set is the display precision, which tells you how many decimal places to show. This is not rounding the values, it's just changing the display, rather like when in Excel where you can change the display of decimal places but not actually truncate the values. So as you can see, it's just set underscore option, then in brackets you put in quotes display.precision, a comma, and then how many decimal places you want to show. I've chosen 2. Obviously you could choose 1, 3, 4, whatever. So that's a nice little option to set if you want to make the tables format nicely without showing too many decimal places. So that's the use of the crosstab function, which I say replicates or does the same thing as the group by function, but I think it does it in a nicer way. Now again, if I'd stored this in its own separate variable, I could then put that, graph that, as I've done here. Here, in fact, have chosen to use the variable that I got from the group by function, but I could have easily have set this equal to a variable and used that instead. So again, we've seen how to plot a bar chart. It's the same syntax as before. So if we show that, we get a nice graph. Now, notice that here, if I had used this, the data in this cross tabulation here, there would have been, again, an extra bar shown for all here, which would have appeared here, which again I think is it could be useful. So it's up to you whether you prefer to use the crosstab or the group by function. You can get the same results in both. I personally think the crosstab is better because of particularly the ability, it gives a nicer printout, and you get these marginal values as well. Now, of course, you're not restricted to just using the mean function here. You could, for example, sum the values here, so you could find what the total total weekly usage was of women who chose Facebook or men who chose Pinterest by putting sum in here to use the sum function, and indeed any function that is appropriate could be used here. I'll just mention, in fact, there is one other way. We've already looked at a couple of ways. There is one other way that you could create a cross tabulation if you wanted. If this only applies if you're going to be using a numeric variable, as we've done here, and aggregating the values. It doesn't work for a simple cross tabulation where you're just counting up the values. Group by and crosstab work fine for that, but this one, which is the function is pivot table. Now, as it says, in fact, in the help system here, if I just look at it, so I'll bring up Shift Tab, you'll see that it does indicate that this returns a data frame in the style of an Excel pivot table. So this is, if you've used pivot tables in Excel, you'll know what they look like. And so this is a function available now which enables you to create pivot tables in a similar way. As I say, it only applies when you're actually aggregating some numeric variable and then breaking that down according to a couple of categorical variables. It doesn't work for a simple count of the values. Notice the syntax is very similar to the crosstab in that you put the first, the difference here is that you actually can put the data frame variable here, then a dot, and then pivot underscore table, so that you can then indicate the index, which is the one, remember, on the down the left, and then the columns, which is on the top here. But then this syntax here is the same as in crosstab: values equals aggregate function equals mean, margin equals true, just the same as in the crosstab function. I'm then storing that in so this will give me the same as what I had here, exactly the same. So if I show that, as you'll see, it's exactly identical to this. So if you prefer to use pivot table because you're used to calling these things pivot tables rather than cross tabulations, if you use Excel, you can use this function. Again, of course, this can be plotted as a nice bar chart here. So by storing it in a variable, I can then simply use that here with the .plot.bar function. All of this we've seen before, this syntax. The only addition here is that I've used plt.legend function to get a better legend, because I found that without that option here, without that function, then the legend didn't look right. It was in the wrong place. It didn't fit. So I've used the legend function here to specifically set a legend which is appropriate. So the couple of options you typically need here are a title for the legend, and then the labels that you want to use, and then the location here. So those three options: title, labels, location. Notice labels, the value for that is a list with the various values that are going to appear in your legend here. Notice, since I'm using this data here, which has got these overall values here, the margins, I do need an extra label here, and obviously title and y-axis label are all the same. So if I show that again, you can see we had a nice one. Now, I think what it did, if I didn't include this, let's look what it does if I don't include this legend function. Now, I haven't touched on this, but you're probably aware that in any coding language you can always put comments in which are not actually run. They're simply there to help. Now, in Python, comments begin with a hash sign. So if I what's called comment out this, if I put a hash sign, that comments out that line. It just turns it into a comment which won't be run. Let's see what we get now if I rerun this command. Well, actually, it seems to have worked okay. I'm very certain that when I did actually run it initially, it didn't produce a nice legend. Maybe I was wrong on that, but anyway, so perhaps I didn't need this legend command. But anyway, you can see that you can, if necessary, if the legend is not printed nicely, you can use this legend option anyway. I'll put it back in. There we go. Okay, as I say, you, of course, are not limited just using the mean function here to aggregate your numeric variable. You could use cite, so I've done that here, using the group by function this time. So that gives me the total usage of Facebook and Pinterest and Twitter broken down by gender. And obviously I can plot a graph of that, like that. This time, of course, I used the group by, so I didn't get the margin values. So I think, again, I would prefer to use either pivot table or crosstab for that. One final thing I want to mention here in this video is carrying out a standard statistical test on a cross tabulation. If you've done any statistics on this, you'll know that what you often want to look at when you're looking at a cross tabulation is to see if there's any association between the two variables. That is, for example, in our case here, where, for example, we look at a cross tabulation between gender and site, is there any does it appear that men, for example, are more likely to choose Facebook and women are more likely to choose Twitter? Is there any kind of, or are they, so in other words, is there some kind of dependence or association between the two values, or are they completely independent? And a standard way of doing that is to calculate what's called the chi-square statistic. I think it's called the Pearson chi-square statistic, to be precise, of association. Now, I'll be looking in later videos at much more, I'll actually be looking at doing statistical inference analysis. In these initial videos, I've looked primarily at sort of descriptive statistics. But so in later videos, I'll be doing a number of videos looking at how to do regression, for example, and how to do other statistical procedures, more sophisticated ones. But a simple statistical test that you can apply to a cross-tabulation, say, is this chi-squared test. Now, this is available in a package called SciPy. I think that's how it's probably pronounced, SCIPY. And that is, in fact, a very standard Python data analysis package, which has a lot of it. I think in many ways it is the standard package for doing a lot of basic statistical analysis. Obviously, you will need to make sure that's installed before you can import it. Now, again, we've seen how to install packages via PyCharm very easily. And so one of the subsections of, I'm not sure if that's the correct phrase, but one of the sections within SciPy is stats. and that contains this contingency, chi-squared contingency function, which is the one we need. So what I've done here is I've imported that, and notice a slightly different syntax here. I've used this syntax here where you put from, and then the package name, import, and then that particular part of the package which contains the functions you need, in this case stats. So it's from SciPy import stats. So I'm not importing the whole of SciPy because it's a big package, there's lots of statistical tests in it and other things. I just need the stats, the functions in the stats section. So once you import that, you can then use the functions within that, and one of them, and there are a number, the one I want is this one here, chi-square underscore contingency. So what you need to do here, what you need to supply to this function is a cross tabulation. So I'm supplying that basic cross tabulation there, which simply breaks down gender against site and gives me a count of values in each of the individual cells. So it's this one up here, but not as proportion, simply as value. So it's the one you'd get if you didn't put normalize equals true and times it by 100, or indeed margins. I don't need the margins. I just want the values in those 6 cells there, but the actual counts rather than the proportions. So that's what I've put into here. Of course, I could have put that into a variable and then simply put that in here, but you can also put the actual syntax to create that cross tabulation, to return that crosstab. So there it is. So there's the syntax. So it will then run a Pearson, it will calculate a Pearson test on that and return the chi-square statistic and the corresponding p-value. It also returns some other things as well. If we just look at the help system of it, you'll see that it tells you this runs a chi-squared of independence of variables in a contingency table. So it's testing whether the values within the cells are independent or whether they're associated in some way. Here's the parameters. Here, all you need, in fact, to say is just the cross tab. What it returns? It returns the chi-square statistic, the test statistic, the corresponding p-value, the degrees of freedom, and the expected frequencies. If you know how this test works and how it's conducted, then you'll recognize what that information is. But you don't really need to understand the underlying statistics too much here to run it. All you need to know is that the null, what we call the null hypothesis, is that there is no association. If the p-value of the test statistic is less than, say, 0.05, that's at what we call a 5% significance value. If it's less than that, then you reject that null and you say that there is some apparent connection between the different values, that they're not independent. If it's not less than 0.05, the p-value, there isn't. So if I run this test, and then, which I've stored the results in this res, and then I print out the test statistic and the p-values. So notice the syntax there. It's res, then dot, and then statistic, and then a comma, res dot p-value. That will give me the 2 values, like that. That's what's called a tuple. That simply means they're in brackets. So we have a test statistic of 0.649. The p-value is 0.772. That is not less than 0.05. So we're not rejecting the null hypothesis of no association. So this is telling me that there doesn't appear to be any particular association between the 2 values. In other words, it looks as though the choice of men and women are independent. There's no indication, for example, that men are more likely to choose Twitter and women more likely to use Facebook, for example. I see. In fact, if you look here from the chart, it does look as if there's no particular difference in the pattern here. Just a couple of final things here to finish off, and this video is getting a bit long. I haven't actually indicated how you can add additional variables to your dataset if you want, and by which I mean variables which are some modification or some are based on the existing variables. It's actually very easy. You simply indicate the name of the new variable here as being part of the data file, the data frame, so df, and then in square brackets, of course, and then inverted commas, the new variable name. So I'm calling this usaging hours per day, and then an expression to create that. And obviously what I need to do is to get per day is to divide those hours per week by 7. So an obvious expression here to do that, and that will then create another variable in my data set. So if I then display df, you'll see there's that new variable that I've created, which I'm getting by dividing each of these values by 7. As you can see, 15 divided by 7 is just over 2, isn't it? 22 is just over 3, and so on. Again, these are being displayed only with 2 decimal places at the most because of me. I set that at the beginning. So it's very easy to create other variables based on the variables existing in your data set, which sometimes you want to do. You want to transform the variables in some way. The other thing you might want to do is to replace some of the values here if you find that they are wrong. For example, you could obviously amend the original data set and then re-import it, but it's easy enough to change values. You simply indicate which values you want, and we've seen how to indicate particular rows and columns. So here I'm saying, and we've seen how to use that using this LOC function. So I'm looking at the values in rows 4 and 5 of the usage variable, usage HPW variable, so that's those 2 values there, and I'm going to change those to equal 10. Maybe I've discovered that those values are wrong, and in fact both of those should be 10. So you can see the syntax, use the syntax that we've seen before and how to indicate those 2 particular values, and then set them equal to a different value. So if I run that and then run the display again, we should find that those 2 particular values, as you can see there, have now changed to both being 10. Up here they were, of course, both 20 and 36. So it's very easy to change values if you need to in the dataset. It's very easy to create additional variables based on the variables already existing in the dataset. Okay, so that completes these 2 videos on doing some basic descriptive type analysis of cross-section data involving categorical variables and numeric variables.